Guys, a very warm welcome to you all. So in today's lecture we all will be seeing what is Doppler's effect in sound. There are basically two Doppler's effect, that is one is Doppler effect in sound and the another one is Doppler effect in light. In today's lecture we will see what is Doppler effect in sound. Suppose you are standing on a platform and a train is coming towards you and the train is continuously blowing the whistle. So, if you'll observe one thing, that as the train comes nearer to you, the sound of the whistle increases, and if the train moves away from you, the sound of the whistle decreases. This is because there is change in the frequency of the sound as the train is in motion. So, the actual frequency of the sound, that is the sound of frequency of the whistle, cannot be heard by us, and thus we hear some apparent frequency as the train is in motion. Now, the for calculating the apparent frequency, which is nothing but equals to Na, the formula is V plus or minus V naught upon V minus plus Vs upon N, where Na is the apparent frequency, V is the actual velocity of the sound, Vo is the velocity of the observer, V is the actual again velocity of the sound, Vs is the velocity of the source, into N is the frequency of the sound, that is the actual frequency of the sound. So we can say that whenever there is relative motion between a source and sound and an observer, there is apparent change in frequency of sound emitted by a source and as heard by the observer. So if something is moving in relative velocity, we can hear the change in difference of sound. So when something is coming towards us, the frequency increases and thus we hear a larger sound, and something is going away from us, the frequency decreases and thus we hear some lesser sound. So let's consider few situations. Suppose the observer is still, that is the observer is not moving, therefore the velocity of the observer will be 0. Now since the observer is not moving, we consider the source that is emitting the sound to be moving in particular motion. Okay, so now if the source is coming towards the observer, that is train is coming toward you now, so therefore the frequency will increase and thus we will hear a larger sound. So now consider this formula is nothing but equals to V. So since observer is not moving, therefore V naught becomes 0 upon V. Now what we should do, either we should write plus or minus. Now since the observer is coming towards you, that is it is coming near you, therefore the frequency increases and you hear a larger sound. So in the denominator you should subtract velocity of the source so that you get the value of Na to be greater. Since Na is inversely proportional to Vs, therefore in order to get the value of Na to be greater, you need to subtract the velocity of the source so that the denominator becomes lesser. Now if the source is moving away from you, so now what happens is that the observer is still and the source is moving away from you. So if the source is moving away from you, the frequency decreases and thus you hear a lesser sound. So over here Na should be less, therefore we add Vs so that the denominator increases. Now let's consider another situation where the source is still, that is the velocity of the source is 0 and the observer is moving towards the source. So now when the observer is moving towards the source, again we consider this equation. So the apparent frequency becomes v over here velocity of the observer, we must add it because when it is moving towards the source we hear a larger sound, so the frequency is increasing, so the apparent frequency Na should be greater. Therefore if we add this in the numerator, the value of this whole sum we will get as greater value. Therefore we add plus v naught upon v, and since vs is 0, therefore 0 into n. Now source is again still and observer is moving away. So when the observer is moving away, suppose the train is standing at one position and it is continuously blowing a train and you are moving away. So as you move away, you hear a lesser sound. You can hear a lesser sound because the frequency is decreasing. Therefore, we want the apparent frequency, that is not the actual frequency of the sound, to be less. Therefore, we subtract v naught in the numerator so that we get the value of this whole thing to be less. Therefore, the apparent frequency now becomes v minus v naught upon v plus 0 into n. So what you have seen in the Doppler effect is that if suppose there is a relative velocity between an observer and a source, the velocity of the sound changes and therefore we hear different sound, that is larger and sometimes louder and sometimes faint. So now if you are moving towards the observer, we hear a greater sound as there is increase in frequency, and suppose you are moving away from the source, we hear a lesser frequency sound, therefore the sound is not that larger. And this is the formula for the Doppler's effect. So guys, thanks for watching the video. Do subscribe to the channel, and you in the playlist you'll be finding all the videos of 11th and 12th science. Just forgot to mention one point, that if both the observer and source are not moving, that is their relative motion between them is 0, therefore there will be no change frequency and the actual frequency will be heard by the source and the sound. Thank you.